Welcome students. In this lecture, we are going to discuss how to find volume of solid of a revolution about the lines other than x-axis or y-axis. We try to solve this question. Sketch the region bounded by the curves y equal to x cube, y equal to 4x, and set up the integrals that can be used to find volume of solid of a revolution if r is revolved about the line y equal to 8. Here we have two curves y equal to x cube and the second one is y equal to 4x. Point of intersection of these two curves are 2, 8, 0, 0 and minus 2, minus 8. You can easily find these point of intersection by solving these two equations y equal to x cube and y equal to 4x. Here y equal to 8 is our axis of revolution. Now we use the relation volume equal to pi time definite integral from a to b outer region square, outer radius square minus inner radius square, inner radius square whole dx. We use this relation to find the volume of solid of revolution about the line y equal to 8. This volume can be written as pi time definite integral from a to b if our outer radius is capital R, so capital R square, and inner radius is small r square dx. Now we find outer and inner radius. Now for the portion of this graph that lies in first quadrant, we have capital R, which is the distance between axis of revolution and outer curve. This is our capital R, and small r is the distance between axis of revolution and inner curve. This is our small r. This whole length is 8 unit. Now capital R is the difference of this whole length minus this distance, and this distance is basically value of y at that point of the curve. So capital R is equal to 8 minus value of y, which is x cube. Similarly, small r is the distance between axis of revolution and inner curve. In this case, small r is equal to this whole length, which is 8 unit, minus this length, and this distance is basically value of y on this curve. So we can write inner radius r is equal to 8 minus 4x. Remember, this radius changes when we move on this line. For this point, our outer radius is capital R and inner radius is this small r. So outer and inner radius for both curves changes as we moved on this line. Now we can find outer and inner radius for the portion of graph in third quadrant. Again, outer radius is the distance between axis of revolution and outer curve. In this case, This whole distance is 8 unit, and our distance is basically this distance plus this distance. Now this distance is 8 unit, and this distance is basically value of y on this curve. As this curve lies in third quadrant and value of y is negative, so capital R is equal to, which is a radius of outer curve, is equal to this length, which is 8 unit, plus this length. This length is value of y, and value of y is negative in third quadrant, so we use a negative sign in front, and the value of y is 4x. Remember, this whole value is positive, as x is negative in this third quadrant. X is less than or equal to 0, and in this case x is greater than or equal to 0. So our outer radius is 8 minus 4x. Our inner radius is the distance from axis of revolution and inner curve, and this radius is equal to this 8 unit length plus this length, and this length is basically value of y on this curve, and again the value of y in third quadrant is negative. Again we use negative sign in front to make this value positive. So our outer inner radius is equal to 8 minus value of y on this curve is x cube. Now we have found outer and inner radius. Now we are in position to set up the integrals for volume of solid of a revolution. So volume in this case for this region is equal to pi time definite integral, as value of x changes from minus 2 to 0, so we write it as minus 2 to 0. Our outer curve is 8 minus 4x, 8 minus 4x outer radius square, and inner radius is 8 minus x cube whole square dx, plus for this region we have the relation pi time definite integral, as x varies from 0 to 2, so we write it as 0 to 2. Our outer radius is 8 minus x cube, 8 minus x cube square, minus inner radius is 8 minus 4x, 8 minus 4x square whole dx. Now this is the relation to find volume of solid of revolution about the line y equal to 8. You can solve this definite integral to find the volume of solid of revolution.